All right. Sorry. Okay. So it seems the recording stopped. But I'm just gonna keep going. So just from wherever we left off from last time. Okay. So it says earlier. So I mentioned that your original amount that you start off with is gonna be $5,000. So P is gonna be $5,000. The account earns 3.5% annual interest. So that's your rate. R equals 3.5%. Divide that by 100 to turn that to a decimal. It's going to be 0.035. And then you want to find the value of the investment when it reaches $12,000. So $12,000, this is your final amount. So, or this is V of T. V of T equals 12,000. Okay. So from this, our goal is to solve for the time because we want to find out when the value of the investment reaches 12,000. So we're taking this formula. We're just taking this formula and we're just plugging in things that we see. Okay, so we know that V of T is going to be $12,000. So this gets substituted here. P is our initial amount that we started off with. So that's how much we started off with. Oh, sorry. This R is a lowercase r. R is our annual interest rate. So that gets plugged in right there. That should be an exponent. There we go. So that's what our expression looks like. Okay, so we're going to graph two functions. Y equals 12,000. And we're going to graph y equals 5,000. E raised to the 0.035 t. Let's see. Okay, so what we're going to do is we go back to decimals and we have to go and graph it. Okay, so y equals 12,000. And we have y equals 5,000. E raised to the 0.035 t. Okay, so as you see here, you can't really see anything, so you gotta zoom in, zoom out if you need to. There's our graph. You look for the intersection points. So you look for the intersection point. Okay, so the intersection point is this right here. So what this means in context is this is t, and this is going to be v of t. So this means at about 25.01 years, I think. Yeah. So what this means is at 25.01 years, the value of the investment will reach $12,000. And that's basically it. Oh yeah, there's another thing I wanted to mention in the other problem. I just realized it now. I think it was this one. So the reason why this one is exponential decay. So if you look at this part here, this 28,000 times 0.905 raised to the t, this number here represents exponential decay because this in parentheses is less than 1. For the problems up here, the number in the parentheses is greater than 1. So if you notice that pattern here, all these numbers greater than 1, it represents exponential growth. The numbers all in here are less than 1, or between 0 and 1, so it's going to be exponential decay, and so forth. Yeah, that's pretty much it. Okay, I think you guys can figure out this assignment now. Okay. That's all I need to say. Okay, bye.